Okay, this is the lighter side of astronomy. This is just a light-hearted look at astronomers and telescopes and observatories, and given that I'm going to keep this to half an hour, that's probably going to be it. There's no more miscellaneous after that. Okay, so that we know that some astronomers are scientists. And in answer to the question, do you think you have what it takes to be a scientist? Well, Sir Patrick would of course say,
well, we just don't know.
And yes, on the right hand side you can see what's going through my head pretty much all of the time. And some astronomers are astrophysicists, and I presume you're all happy with what's on the blackboard here. We'll start from that level and then just jack it up a little bit. Astrophysicists seem to have the knack of taking a wonderful hobby and turning it into absolute gobbledygook. But we know that astronomers are keen on classifying things, for instance classifying stars. I'm sure a lot of you will have seen the Hertzsprung-Russell or HR diagram, in which stars are classified by their luminosity on the vertical scale and the temperature, or the colour if you prefer, the surface temperature, on the horizontal scale. But a little while ago somebody said, well, if astronomers are keen on classifying stars this way, why don't we classify astronomers? So they produced an HR diagram of astronomers, and here the vertical scale, the luminosity of the astronomer, is given by how famous they are, and you can quantify that. Well, in principle you can quantify it in different ways, but here it's been quantified by how many hits do you find if you put their name into Google. And the horizontal scale, again in honour of the HR diagram, this runs from right to left rather than the other way round. This is the number of scientific papers, number of peer-reviewed scientific papers that the individual has published. And then we can plot various astronomers in various positions. And I'm not going to ask for a show of hands, but I ask you to think about, if you look in the top left, who do you think that might be? The person who's the highest on this fame category and the furthest left as far as reviewed scientific papers is concerned. I'll give you just a few seconds so you can all just contemplate who is that individual. That is Carl Sagan, the most famous and the most prolific astronomer according to this particular diagram. This diagram was put together a few years ago, so I'm not vouching for the accuracy of either the Google hits or the scientific papers. Right next door to Carl Sagan there is Stephen Hawking, marginally more famous perhaps because of the age he was born into, rather than Carl Sagan spending most of his time in terms of popularity in the 1980s. But there's Stephen Hawking with a couple of hundred papers. Further over to the right there we see, not quite as famous and a long way to the right with something like 20 scientific papers, that's Brian Cox. And for some bizarre reason, if we go right over to the right hand side of the diagram there, we find an individual who's almost as famous but has got 0 scientific papers. Okay, on a log scale 0 ought to be off to the right hand side, but here it's just snuck its way into the diagram. That is Mylene Klass. Given that she's not an astronomer but is an individual who I think has hosted the odd TV programme, that's why she occurs at that particular point. Other individuals you probably know: Neil deGrasse Tyson, Chris Lintott, Jocelyn Bell Burnell, for instance. And I thought this was quite interesting to see where these individuals occurred on this HR diagram of astronomers. But when I looked at this, I thought, well, given that this is Google hits on the vertical axis and scientific papers on the horizontal axis, it doesn't say scientific papers in astrophysical journals. So I thought, I wonder. I have written a number of scientific papers, and I thought, where would I occur on this diagram? I'm not going to be up there with the supergiants. I hope I'm not down there at the bottom amongst the dark astronomers who are quite productive, but nobody's ever heard of them. So I wonder where I would occur on this diagram. So I did what sooner or later everybody tends to do. I put my name into Google. Googling Steve Barrett isn't very helpful because there's lots of Steve Barretts in the world. Googling Dr. Steve Barrett doesn't help because there are a number of Steve Barretts with PhDs. There's a few in America and a few in England. So I tried Googling to try and make sure I didn't pick up any spurious individuals. I Googled Dr. Steve Barrett, Liverpool, and that, I think, hit me, and I checked that the first of these Google hits were genuine. That produced 5,000 Google hits. So I thought, right, 5,000 hits, 5,000 on the log scale is somewhere around here, and I've written about 100 and something papers, so I should be somewhere around here, and indeed, bang, that's where I occur on this HR diagram. Right slap bang in the middle of the main sequence. Which tells me what I've known all along: I'm an absolutely mediocre scientist. Let's have a look at a few cartoons. This one I quite like, a caveman looking through a hollow log, saying, nope, moon still looks the same. You say this is the most powerful one you have? I think this is funny for a number of different reasons. A, the joke that they're looking through a hollow log with a magnification of, presumably, ×1. And he's a bit disappointed that the moon isn't magnified. But I think somewhat funnier than that is the fact that over on the right-hand side here, we see a telescope, and strapped to the side of this hollow log is a smaller hollow log. Presumably that's a finder log. Same magnification of ×1. Whether that actually helps you find a star or a moon, I don't know, but it's a cute idea. But the other thing I find funny about this cartoon is that the caveman on the left clearly wants to buy a telescope and is disappointed by the magnification. But the caveman on the right is clearly the salesman. You can tell that because A, the coiffured haircut, but B, you can tell this caveman is the salesman because the caveman is wearing a tie. What a great idea. Ancient ways of telling the time and telling the date, of course, have been around for a long time. Here we see an individual noticing that the sun is going through a partial eclipse, and then we have a total eclipse in the middle pane there. Everything goes dark, and then the sun reappears. At which point he has to call in the sundial repairman. Why? Well, because after the eclipse, when the sun returns, it happened right after the eclipse, it just keeps blinking 12 o'clock. Anybody with a microwave will understand the frustration there. And of course we know about stone circles, we know about the idea of an object like Stonehenge. Is it a clock? Is it a calendar? Well, perhaps a little bit of both. And here you can see one of the architects of Stonehenge telling the other one, well, remember, when summertime ends, we have to give everything a slight turn to the left. And when it comes to thinking about how these huge stones were moved, you can ask the question, how on earth did the ancients manage to move these massive stones? To which Sir Patrick would again answer, well, we just don't know. But the hint in this case is given on the left-hand side of the stones, where we get a clue as to how they were moved. Let's have a think about some astronomers. Again, we're not going to go through many. Let's start with Galileo. Galileo, famous for his astronomical work and the fact that he, as a physicist, tried to work out how things actually behave rather than how things should behave. Reputed to have thrown cannonballs off the Leaning Tower of Pisa to time how long they take to hit the ground, to do an experiment rather than guess how long it should take. And some people have said, well, if there were computers in Galileo's time, would that have made his experiments even more accurate? Well, perhaps, but it's perhaps more likely that if Galileo did have computers in his time, he's more likely to have thrown the computers off the top of the Leaning Tower of Pisa. What about Isaac Newton? Everybody knows the story of Isaac Newton sitting in the orchard outside Woolsthorpe Manor in Lincolnshire, pondering who knows what, and then an apple falls on his head and he starts thinking about gravity, and this leads to the discovery of universal gravity. But it's not often appreciated that shortly after Newton discovered gravity, that same afternoon, Newton discovered comedy. And for those of you with a particular sense of humour, even more bizarrely than that, later in the evening, Newton discovered surrealism. And I do love the idea of a grand piano falling out of an apple tree. What about our friend Carl Sagan? We saw where he fitted into the HR diagram in the very top left. Gary Larson had a nice cartoon about Carl Sagan. Carl Sagan as a kid, just look at all those stars. There must be hundreds of them. And for those of you who don't get that joke, you can't have heard anything that Sagan said throughout the 1980s, especially in his Cosmos TV series. Let's have a look at a few telescopes. Here we see a design that I think is from the Victorian era. I've never actually seen the telescope itself, so maybe this was never built. But it's a wonderful idea because if you look at the mechanics of how this telescope has been designed, you realise that no matter where the telescope points in the sky, the eyepiece always stays in the same place. Which means once you've decided that for a given height astronomer you need to stand in a particular place, then they can stay in that place regardless of where the telescope points. And of course amateur astronomers over the ages have been extremely good at making telescopes. This, for instance, is a very nice example of a telescope, a reflecting telescope, a Cassegrain design. You can argue about the reason for making a reflecting telescope from very reflecting metal. That's perhaps not such a good idea, but you can't argue against the craftsmanship of the individual who made a telescope like this. And of course there's many examples of amateurs who've indicated their skill at making telescopes. Okay, some perhaps haven't really got a clue as to how to go about it, but others are extremely gifted. If we think about the smallest telescopes that amateurs have built, if we think about the smallest fork-mounted telescope, perhaps some of you have a fork-mounted telescope which you might use on a tripod or you might use in your observatory, but I would argue that probably you haven't got a fork-mounted telescope that looks quite like this one. Here we see the fork-mounted telescope, which is clearly in a fork, and the fork is also attached to a knife and spoon, which gives you a very nice tripod, which is a wonderful idea. And in answer to the question, is this probably the best telescope in the world on the small side of things, you can perhaps tell from the phrasing, probably the best telescope in the world is obviously one that's made out of a Carlsberg beer can. Here they've taken the top off the can, put a small mirror in the bottom, in much the same way that Newton did, and a small 45-degree mirror on the eyepiece punched into the side of the can makes a small Newtonian telescope. I would argue it's probably not the best optical quality in the world, but I'm told the person that produced that telescope did confirm that it does actually work. And why would you limit yourself to one telescope when you can buy or make two? Here the idea is that a couple of Dobsonian telescopes in the same cradle can have the two eyepieces brought to a convenient distance apart and then can be used as a pair of binoculars. And I would guess those are something of order 12-inch diameter mirrors or something in those Dobos, and I would imagine they give you superb views of the sky. But you don't have to limit yourself to 12-inch when you can go a little bit larger. I'm not too sure what the mirror size is here. Obviously a skeleton telescope in this case. And in order to get your eye line to the eyepieces at the top there, then you need to be either very tall or you need a stepladder. And for some people, even two is not enough. And when thinking about buying a large aperture telescope, some organisations have gone down the route of, rather than find a large amount of money and build a large aperture telescope, why not start with a small telescope, in other words a photographic lens such as a 400mm f2.8 lens, this happens to be a Canon, and then you can put more than one of them together. It has the advantage you don't have to find all the money at once. You can find enough money to buy one or two, and then if more money becomes available you can buy more and build up your collection and effectively get a much larger aperture. Also has the advantage that you can put a separate camera on the back of each lens, and each camera can either photograph the same object in the same filtered light, or if you wish, you can take a lot of parallel images with each camera with a different filter, or a couple of cameras with one filter, or a couple of cameras with a different filter, etc. And then you can take all your images at the same time, rather than take one image with a particular filter and then hope the clouds don't reel in, take another filter and then take another filter, etc. And if you're going to go down that road, okay, you need a fairly substantial mount if you're going to put 10 of them together, but you don't have to stop at 10. You can take it further if you wish, and here there are 24 cameras and telescopes all on the same equatorial mount. I believe that this particular group now has 48 of these cameras and lenses. And of course size does matter, as we all know. If you're going to build yourself, for instance, a Dobsonian telescope, you may as well build yourself a large one. And this looks like a dark sky sight to me from the looks of it being so remote. I would imagine that this is a little bit scary. If you're going to be that high on a step ladder in a very dark area, I would imagine that takes a certain amount of nerve to use that telescope properly. And if you ask yourself what's the largest refractor ever made rather than the largest reflector, a lot of people will think, of course, of the 40-inch Yerkes refractor. But that wasn't actually the largest refractor ever made. It was this one, with an objective lens of 48 inches, so a little bit bigger than the Yerkes refractor. This telescope, the tube of which you can see here, is mounted horizontally. You can see it in this panel at the top, where the telescope tube is mounted on a great deal of pillars, a number of pillars, and the whole telescope is static, and it looks at different parts of the sky from this mirror here, the siderostat, which is oriented to bring light from the chosen object into the telescope. And again, if we refer back to this picture of the building at the top there, there's the siderostat on the left. It directs the light down the telescope to either photographic film or a large eyepiece, which then, using eyepiece projection, would project an image of the sun or the moon onto this huge auditorium screen. And in the 1900 Great Exhibition of Paris, I would imagine this was an absolutely phenomenal draw, in that the audience will not have seen live images of the moon or the sun in the sort of spectacular detail and size that this telescope could deliver. So we see here is the objective end of the telescope, a very long tube, and here is the business end with the eyepiece or the photographic film. If we have a look at an image taken looking from the photographic plate down the tube, so the objective lens and the siderostat mirror are at the far end, we can see by comparing with the size of the people here just how large these photographic plates would have been, something of order 24-inch square or something like that. And I couldn't find an image of the eyepiece, but there's the eyepiece holder, again with a person to give you an idea of sense of scale. So you can get an idea of how big the individual eyepieces would have been. To the best of my knowledge, although this telescope was built for the Great Exhibition in 1900, held in Paris, as far as I know, after the exhibition it wasn't used any longer. The 48-inch objective lens was put into a museum, and the rest of the metal tubing of the telescope was simply sold for scrap. What a shame. But of course not all telescopes are made of metal. Some people prefer to work in wood. And here an enterprising individual has decided to make a full-size model of the Hubble Space Telescope, made out of plywood. And I presume they need a very large garage, if not a warehouse, to house that. Some people are quite much happier to work in wood on smaller scales. For instance, people will make Dobsonians out of wood. This looks a little bit more like a cannon, but yes, here a Dobsonian, a large cylinder on a relatively simple mount, relatively straightforward to make. Other people prefer to make their telescopes by buying an optical tube assembly, but still putting in their handiwork into the manufacture of, as in this case, a wooden equatorial mounting. And of course there's no limit to the individual ingenuity of individuals who want to make telescopes. The famous amateur telescope maker Russell Porter made this, which is either a telescope or a garden ornament, or if you prefer, both. So there's a small mirror down the base here, and a 45-degree mirror and small eyepiece makes this a very compact Newtonian. But clearly it was made more as a garden ornament than it was a serious telescope. But anybody who does have a telescope, whether it's one they made themselves or one they've bought, always starts to think, well, if I've got this telescope, do I want to take it in and outdoors all the time, or do I want a back garden observatory? And most people would like to have an observatory like this one. This is the observatory on Palomar Mountain, the home of the 5-metre or 200-inch Hale telescope. Beautiful setting. I visited it back in 1982. It looks like, according to that picture, I think I've got the same shirt still. Yeah, it probably is the same shirt. So that was 1982. I visited the Hale reflector. I thought, what a fantastic telescope. It was the world's largest telescope when I was born, and it remained the world's largest telescope for most of my life. And when I saw that and I saw the observatory, I thought, that's fantastic. When I grow up, I'm going to buy a house with a back garden big enough to put one of those in. Okay, I had to downsize my aspirations somewhat, but a few years later I bought a house in which I could fit just about an 8x6 shed, which I converted into an observatory, and that tucked just behind the garage. I jigsawed a hole for the telescope here in the base, and the roof I replaced with a load of folding panels that hinged back to reveal the sky. This is a picture taken very soon after I modified the shed to make an observatory. You can tell it's new mainly because there are no spiders in it. You can also tell the age. You can tell this is 20 years old, not necessarily from the Schmidt-Cassegrain telescope, but from the laptop sitting in the background, which looks more like a house brick than it does the thin things that you get these days that call themselves laptops. And some people take craftsmanship to the next level when it comes to building an observatory. Rather than going out and saying, well, I can always buy or even make a fiberglass observatory dome, here they've made a hemispherical dome, a geodesic dome out of wooden triangles, and then making them into pentagons and hexagons. Absolute work of art. The downside, of course, with an observatory is it's in your back garden, which is really convenient, unless you happen to live in an area which doesn't have particularly dark skies, in which case you have the problem of, well, it's great to be convenient in my back garden, but what I really want is to be able to take the telescope somewhere where the dark skies are, which aren't necessarily where I live. So it would be nice to be able to take the observatory with you, but that's of course a crazy idea to actually have a mobile observatory. Well, maybe not so. There's no reason why you can't have a caravan observatory. Maybe that's got a name, but here we can see a not insubstantial sized observatory on the end of a caravan. What a fantastic idea. You take it to whatever dark sky site you want to use, you do all your observing. When you've had enough, bang, you crash into the bed next door. Great idea. But perhaps that's a little bit too large. Maybe you own a car which is not so large and you'd have difficulty towing something quite as large as that, in which case you would like to have something a little bit smaller. Well, yes, they do come in smaller sizes. There's a nice little easily mobile observatory. And of course, again, you want to take your telescope to a dark sky. Maybe you don't think it's necessary to take the observatory with you. As long as your telescope is on wheels, you can take that anywhere you want to go. So this is obviously a wonderful go-to telescope. I've got no idea if you need a license to drive this thing, but it appears to be a very useful and quite a reasonable size. It's not a Dobsonian by the looks of it. It looks like it could be an equatorial mounting, but it looks like you can take it anywhere. By no means the first example of a telescope on wheels. That's one of the earliest versions I could find. This looks like something like an 8 or perhaps a 9-inch refracting telescope, a bit of a beauty, stuck on top of a car. And you might say, well, that's very limited. Surely you can't get much elevation. You can't see objects at a very high altitude with a setup like this. But no, there is a crank handle on the side. So if you wish, you can crank it up and then your telescope is able to be used across a fairly large chunk of the sky, if not absolutely the zenith. And when you look at that, you think, is that for real? Surely, is this a publicity photo of some kind? Was it made by the people who made the car? Was it made by the people who made the telescope? I couldn't find the manufacturer of the telescope in this particular case. But you look at that and you think, that can't be right. I mean, the car is unstable. Surely you'd never be able to see any objects with a telescope of that size. Nobody would be crazy enough to put a telescope of that size on the roof of a car. Unless you're American, in which case it makes perfect sense. And here's an individual who at the time lived in Florida, and again he has a large refractor. I can't quite see, perhaps it's 8" or thereabouts in aperture, and clearly it's on the back of a Volvo here. Notice the back bumper of the Volvo has a little bit of block of wood underneath it, presumably to try and steady out the suspension of the car such that the telescope could actually be used. So whether this individual roamed around Florida to find the darkest skies, I don't know. Maybe he lived in Miami and there was too much light pollution there and so wanted to get further out into the countryside. Is that the largest example I could find of a mobile telescope? Well, almost, but the only one that I think is significantly bigger and more expensive than that is the SOFIA Stratospheric Observatory for Infrared Astronomy, and there's the telescope in the back looking through an open hatch, an infrared telescope. It's flown in a 747 because they want to get above as much as the atmosphere as possible, because the atmosphere absorbs infrared light. So if you want to do your astronomy, it's very expensive to go into orbit. It's not quite so expensive to put your telescope in the back of a 747. Still, that is $100 million worth, and I think it's outside the reach of most astronomers, so perhaps I ought to tie up the talk here and simply acknowledge the places where I found these cartoons and jokes that made me chuckle, and I hope you found that interesting to listen to the lighter side of astronomy. Thank you all very much for listening.